types of organic reaction. So in general, there are 7 types of this organic reactions, and for this please refer to page number 12.74. Page number 12.74. So refer to this page number, and here you will find all these types of reactions. So the first organic reaction is rearrangement reaction. The second one, substitution. The third, addition. Then we have elimination. Then we have polymerization, condensation, and the last one is isomerization. So there are 7 types of organic reactions, and we are going to discuss them now in detail. So the first one that we have is rearrangement reaction. Rearrangement reaction. So in this type of organic reaction, what happens is, now certain organic compounds, mostly an alkane, now they, under the presence of aluminum trichloride and certain suitable condition, they will rearrange to form iso or new alkane. So whenever I write the example, it will be more clear. So we have this such type of reaction where we have this CH2, and CH2. So in presence of aluminum trichloride, and we have certain suitable condition, that is 300 degrees centigrade. So in presence of aluminum trichloride and temperature being 300 degrees centigrade, what will happen? Here, rearrangement within the molecule will take place. Okay, so you obtained this compound, CH3, CH3, and H. So you can count the number of carbons and hydrogens. It is exactly the same. So here we have 4 carbons, here also 4 carbons, and there are 10 hydrogens. Here also you can count it to be 10. So why does this rearrangement reaction takes place? Why? What drives it to undergo, to be converted into this? The reason behind this is stability. So here you can see that this carbon and this carbon, they are second degree carbon. So I have already taught you about what are first degree, second degree, and tertiary carbons. So here this carbon is directly attached to how many carbons? 2 carbons. Therefore this is second degree carbon. Second degree. This carbon, likewise this carbon is also directly attached to 2 carbons. This is also second degree. Now you can look at this carbon. This carbon is attached directly to how many carbons? 3 carbons. This is third degree carbon. Now the reason behind this being converted to this isomer is its stability. Third degree alkanes, okay, are more stable than the second degree alkanes. So the stability is the main reason behind such rearrangement reactions. Now let's discuss about another type of reaction, that is substitution reaction. And this substitution reaction is very, very important. Okay, it is there in class 12 as well. So please listen to it carefully. Substitution reaction. So next one that we have is this is number 2. Substitution reaction. Now in substitution reaction, the name suggests what takes place? Substitution takes place. So suppose you have some, say, RCH2, say halogen, alkyl halide, say BR. Now whenever it is treated with aqueous KOH, then what will happen? This bromine will be substituted with this OH. Here this is delta negative, this is delta positive, here this is positive and this is negative. Therefore, the negative has to be substituted with negative. nucleus slowly, OH minus. This is also known as what? Nucleophilic substitution reaction. So in such reactions, what we get is RCS2 and OH. And your byproduct will be KBr. Your byproduct is KBr. Now here what has happened? Br is being substituted or replaced by OH with who? OH. Such type of reaction is known as what? Substitution reaction. And here since nucleophile is substituting, then this is known as what? Nucleophilic substitution reaction. Now there are two types of nucleophilic substitution reactions. Okay? There are two types, please remember. One is SN1 reaction, the other one is SN2 reaction. And the mechanism as well as the product being formed out of this SN1 or SN2 reactions are very important. And as I told you, this is there in your IC class 12 also. So let's discuss about this nucleophilic substitution reaction. The first one is SN1 reactions. This SN1 reaction is substitution nucleophilic unimolecular. So substitution nucleophilic unimolecular is the name of this particular reaction. Here, this SN1 type of reaction is given by tertiary alkyl halide. Tertiary alkyl halide means third degree alkyl halide. And there are two steps in which this reaction takes place. So let me write tertiary alkyl halide first. CH3, C, CH3, CH3, and we can say BR alkyl halide. So whenever it is prepared with aqueous, please remember this is aqueous KOH, and substitution reaction takes place, and the product that is obtained is CH3, C, CH3, CH3 and OH. And the byproduct that we get is KBr. So here this is the substitution reaction taking place in third degree alkyl halide. Now how does this reaction take place? What is the mechanism? What is the path followed by this reaction to be converted into the product? This reactant to be converted into the product. So here we have two steps. In case of SN1 reaction, these two steps you have to remember it properly. So mechanism. We are going to discuss about mechanism of SN1 reaction. So in the first step, we have CH3, C, CH3, and here is CH3, and BR is present. So in the first step, this is the slow step. This is the slower step. The breaking of the bond takes place. Here this is delta negative, this is delta positive. Now the bond between carbon and bromine will break heterolytically. As a result, we get CH3, C, CH3, CH3, and here positive plus Br minus. Now you can see here, this is carbon with positive charge is what? Carbocation. So in the first step, carbocation is generated. And this is the slower step. Now, the rate of this reaction is determined by this first step itself, formation of carbocation. In the second step, now nucleophilic addition reaction takes place. So this is the first step. Let me write a second step here. This is SN1 reaction we are discussing about. So in the second step, what happens is this carbocation that is being generated, CH3C, CH3, CH3 plus this carbocation. Now nucleophilic addition reaction takes place. So here what we have is we have aqueous KOH, that is K plus and OH minus. So we have this reagent K plus and OH minus. Now here this OH minus will come and get attached to this carbocation. It can come from this side or it can come from this side. So you get a same product. The same molecular formula will be same. That is CH3, 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 and here you get OH. Now, since this OH group can get attached to this carbon either towards this side or from the other side, therefore we get racemic mixture. Racemic mixture. So I have taught you about what is racemic mixture. Racemic mixture is 50% dextrorotatory and 50% is laterorotatory. So their optical activity will be different, but the molecular formula is same. So you get this compound and this here. This is racemic mixture. Racemic mixture. And you know the name of this compound. So you can name it as 1, 2, 3. So 2-methyl-prop-N-ol. So the name of this compound we already know it. I wish you know this. We have discussed. So these are the 2 steps of SN1 reaction. Now let's discuss about SN2 reaction. Okay, SN2 reaction. Now SN2 reaction SN2 reaction. Substitution, nucleophilic, 2 means biomolecular. So such reaction takes place in first degree alkyl halide. So first degree alkyl halide or primary alkyl halide undergo SN2 pathway of substitution reaction. So this is a single step reaction. Here it is a single step reaction. Here mating and breaking of the bond takes place simultaneously. So let me write this CS3, say BR, this is first degree alkyl halide, you can say this is, so you can take first degree alkyl halide. So for that you have to take CS3, CS2 and say BR. Now, in presence of QOH, what will happen is, now let me write this QOH here, and what will happen here is you have OH minus, the same OH minus I'm writing it here so that I can show you how it gets attached to this carbon center. Okay, this is delta negative, this is delta positive. Now this OH minus nucleophile will approach this carbon center from 180 degree behind of this BR minus. So once it is approaching, then this bond will try to break. So in between, what you have is you have say CS2, and here I write CS3 here, and this bond is between carbon and BR is in the process of being broken, and the bond between OH and C is in the process of being formed. Now this state is known as what? Transition state. So I already talked about what is the difference between intermediate and transition state. Transition state, they cannot be isolated. So then once this reaction takes place, what is the product obtained? You get CS3, CS2, CS3 and OH. Okay, so here you can see that your BR was present on the right hand side. Now the incoming nucleophile has come on the other side, that is 180 degree to the other side of BR. Now such reactions are what? They are inversion reactions. They are what? Inversion reaction. So if you're starting this say alkyl halide was say dextrorotatory, then the product that you obtain after inversion reaction is what? Laterorotatory. So you have to remember, if in case of SN2 reactions, since the nucleophile is being bonded at 180 degree behind the BR minus, then its optical rotation will vary. If the reactant was dextrorotatory, the product that you obtain will be laterorotatory. So you have to remember, this is your inverted product. Inverted product. And this takes place in one simple single step. And why it is known as a biomolecular reaction? Why two? Because here you have only one step, and in the same step, both the concentration of KOH as well as the concentration of alkyl halide, they are involved. Okay, the redetermining step. Therefore, they are known as what? Biomolecular. In case of SN1, in the first step you have slower step, and the slowest step is always the redetermining step. And in that first step of SN1 reaction, only the concentration of alkyl halide was involved. Therefore, since one concentration term was only involved, that's why that was known as what? SN1 reaction. So we'll be discussing about other types of reaction in next video. Till then, keep revising. Thank you.